So, hello everyone, I'm Raghav, and today we are going to be giving a Div3 contest on Codeforces. And like it is an unrated contest for me, so I will try to explain the like how to do the problems in the contest itself. And Shasha found an array A consisting of an integer and one array elements. It's maximum possible cost. Okay, so for finding the maximum possible cost, what I will try to do. How many colors do I have? In case if I'm having just two colors, then I will put all the elements. Yeah, so I have only two colors, I guess. You can use as many colors as you want to. So for the smallest and the largest value, I will put them in one color, like give them the same color. For the second smallest and the second largest, I will again give them the same color, which is gonna be different from the earlier one. So like in this way, you will be able to get the maximum like differences, and adding their sum, you will have the maximum value. So here in the problem, what I could have done was to get 6 and 1 and 5 and 3. So it will be 2 and 5, so 7. And yeah, they also got 7. So let's write it. I am having an array of sizes, so let's do it like this. And then just take the inputs, and then you have to sort it. And after that, let's declare an answer variable and just traverse the array. You have to traverse only the half of the array, because like every time you are basically just covering this one and this one, this one, this one. So when you if you cover the whole array, then every pair will be considered like counted twice. You want to consider them only once, so that's why we will do it like this. We created an array ARR, so n minus. This is the last, like ith element from the last. Basically, if I is 1, then this is n minus 1. I is 0, then this is n minus 1, and this is 0. For 1, it will be n minus 2 and ARR of 1. So, in this way, everything will be covered once. And then you can just see what the C out answer, and enter. Let's see if it works. 701123, 701123, 0 and 5. This it's working. We have something like a CP and something like this. We'll get some method number. Take my problem about something like that. For the second problem, today Alex was about array A of any equations. In one equation, Alex uses any range. all the elements, multiply all the elements from L2R by minus 1 and the range will be like this, okay? And Alex set to school, so the maximum sum of numbers in the array which can be obtained from I think any number of operations as well as the minimum number of operations must be done for this. Okay. And the maximum possible sum. So do I have to tell the number of operations or the sum? Okay, I have to tell both of them. Obviously, the maximum sum is going to be the absolute sum of all of the elements, right? Because I can just multiply all the negative elements by minus 1, and in that way I will have like all the elements positive, so their sum is going to be the maximum sum I can obtain. And to find the max like minimum number of operations, you can try something like this, that just like all the minus negative elements which are coming together, just multiply them by minus 1 at once. So in that way you will be able to like uh, here you have these four elements in which if you multiply them by minus 1, like for zeros there will nothing will happen, and for the negative ones they will become positive, right? So instead of applying operations on them like separately, you can just apply operation on them together. So that's what you can do. And write this also. So we are having, like in the inputs we are having an integer n and an array. Let's write this. And you don't now you have to make an answer variable which we will see out at the end. And for this array what we can do here is that if there is a like if the current element is less than 0, if the current element is less than 0, like let's say that if it is greater than equal to 0, in that case just go ahead, and for the other case when it is less than 0, only then we will be applying some operation. And in this like we will do something and the counter will increase because we are applying the operation. So here the idea is that once you find an element, let me explain. So here the idea is that once you find a negative element, just keep going ahead until you find a positive element. So if there is any 0 or minus 2 in between, you will like just multiply everything by minus 1 until there is a positive element. If there is a positive element, then just like stop going ahead and go to the next iteration of I. So we are going to be using two pointers here, and we'll do the operation in this one. So here we will say that like just declare a variable j here, j is equal to I, and while j is less than n and here our j is less than or equal to 0, in that case just keep saying that arr j, or maybe you don't just say anything, and like you don't really need to say anything and just go ahead, just increment j, and at the end just say that I is equal to j minus 1. Yeah. And at the end you can just print the answer. Let's do this. 32111, like 32111, yeah, this is correct, the number of operations, and the other part was to print the sum also. So we can just say that int sum equal to 0, and like for every element you will just increment the absolute of arri, and here you will just print that sum, and then like this. So 2025, it's giving the answer. It's like, yeah, yeah, I missed something. Yeah, this is not correct. Or like I can just run another loop. Like the mistake was that when I am incrementing j, so some elements will be missed, which will not be included here. So one thing I can do is to like add it here only, and the other thing is that just calculate it separately. It's going to be really simple in that way. Now I have 27, 7, 13, 18, 4. Yeah, that's correct. So just try to submit this also. Okay, so now Why I have to verify that I am a human? It's basically get accepted. Let's go to the third problem. Accepted. And now in the third problem, it is saying that we have like binary tree. Vanya likes maths, really likes maths. One day when he was traveling, thinking that initially that tree has only one vertex with the number 1 minus the root of the tree. Okay, so it is just one number and which is the root of the tree. And then Vanya adds two children to it. But all the children just starting something like this. Okay. Here, which is children. Notice how what the sum of the vertex numbers to the vertex such a tree sequence. So this is a standard problem which I doesn't remember how to do. So we have to think about it then. I like yeah. I have in the like the number I have here. So I will be given a some number and like this is one here. This is two into one. This is 2 into 1 plus 1, right? And here if you see that this is like 2, so this is 2 into 2, this is 2 into 2 plus 1. The binary tree is having this kind of indices. So like here it is 3, so it is going to be 3 into 2. This is going to be 3 into 2 plus 1. And in this way, like the tree is in this way. So when I'm given a number n, I know that like if even if it is even or odd, the parent of it is going to be equal to n by 2. And it will keep like we just have to do like this again and again until we reach 1. So basically, you just need to have find the sum of n plus n by 2 plus n by 4 plus until you reach 1. That's what we have to do in this problem. So let's do it. We are going to be given just a number and nothing else, and we will have to output an answer. So let's answer signal, which we will have to print at some point of time. And here you will be just saying that while n exists, just keep saying then answer plus n and n equal to 2 by like just divide it by 2. The code is pretty short. 4871 4871 and a very huge number and 126. So let's try to submit this. I hope it gets submitted directly and it will also get submitted. Let's go to the team problem. That also got submitted. So let's see the leaderboard. I'm having a pretty bad hand right now. Like, really bad. As an apple cake, when you start it is a relatively with the game. At least I can have without loops again. And it is very much sure that it goes with it groups upwards. Like this contest is pretty like educational since you see that even in the third problem they taught you the like standard technique. Now the apple tree is quite young, so only two apples goes on it. The apple will attain and after the apple goes apple. Each time Timothy shakes the apple tree, the following things let's say if the apple now we have the vertex u, if the apple means a sign, the apple moves straight. Uh, there are several such cases that apple can move back and forth, the rest apple is just it can be shown that after the night time it will ultimately as clear solutions in which the since Apple scan code to vertex XY and remove the vertices XY and remove the number of layers of vertices A to B from which apples can fall from the tree where A the vertex and the I didn't really understand the problem properly here. Let's see the test. I'm already been given a tree. So the tree is something like this, and I'm also being given something else. Uh, I'm being given the vertices, and I'm being given about the edges. Then I have an integer q, uh, it's something like queries, and then there are some queries, and I have to output some answer there. So for the first assumption, where at two possible points, this is the first assumption, 3, 4, 2. So if it is 3 and 4, like for the fourth one, it is definitely gonna be 4. For 3, there can be like 4 or 5, and for like there are only these two things. So the number of test cases should be the below maximum. And for 3, comma 4, then 5, 5, comma 1. So for 5, there is only one thing that is 5, and for 1, it can be either 4 or 5. So it will be 4, comma 5 or 5, comma 5. And for the third assumption, it is 4, comma 4. Yeah, I don't have any other choice. So basically, I just need to keep going to its children and have to print, like find all the possible children of a number. Maybe I should recalculate it some way that for all the leaf nodes, these will be the children of themselves. Like I will create a 2D matrix, and like for 4, I will say that if an apple is at the index 4 or at the node 4, then it will fall at the node 4 only. For 5, I can say the same. Then I will talk about 3. So I will say that for the node 3, it can fall at apple 4 or 5. Like there are two choices. And then for 2, I will say that all of the choices for 3. Then for 1, I will say that all of the choices for 2. And I will get some, I think that it will work. Let's see the problem also. Like this B problem will have some sort of implementation. Maybe something. Nothing starts. I was why was I so slow? Yeah. You are being given an array consisting of n zeros or also being given a set of n consists of different segments. The segment is defined as pattern rows. Okay. That's for a segment detail of the number of ones in a sequence. Changes. They also have two changes. For each change, you are being given. Okay. You have to find the first change after which at least one of the n given segments become beautiful or both become nothing. M can be too huge and Q can be also too huge. So directly like brute force method will not work for this problem here. Now let's see that problems. Like this problem, this contest is not rated for me, so that's why I'm so chill. Like let's see the other problems. Otherwise, I would have been writing the code for D. Let's see the D problem. So basically, I'm going to initially all of them are 0, I guess. Yeah, all of them are 0. So once I make someone as 1, we'll make a change there and cannot actually check for every segment again and again. So what if I say that for every segment, uh, So basically half or like more than half of the size of the range should be having ones. Okay, so something like checking for range information. Five and three. When I make a change, so it will get toggled. Most decided gives the level. So like five and three. Then, like when you say five, you can't actually go to all of the ranges and set it. Then it's this and at the side of five and number of segments. And so let's see the D problem first. So basically in the D problem, what we have to do, we are being given the root at least, I think. We are being given the root. And the purpose is, like there should be a root, I think. This is, how will I know which one is up and which one is down? Yeah, root is at one first index. So what I will do is like I will start a DFS function from this root and I will just keep going to depth and depth. And for every time, whenever I reach leaf node, I will say just like I will be having a 2D matrix in which okay, this like this that I am gonna be having this kind of like this is a vector in which every element is gonna be a vector of integer. All of the elements are going to be vector of integers in themselves. And like when I reach the node 4, so let's say if there is index 4 here, so I will just put up 4 here. When I reach 5, I will just put up 5 here. And when I reach 3, so in that case, what I will do is like one thing is that I will put up 3, not 3. Okay. Since 3 is not the leaf node, so I will just look up to its children that there is 4 and 5 here. So for both of the children, I will say that like since there is three and like 4 and 5, so I will say that all of the leaf nodes which can be reached by you, just give me them and I will push them here. Then let's say I reach two here, so I'm talking about two, then I will say that all the leaf nodes which can be reached by three, just push them here, and the same for one. And like this can be done by just a DFS function starting from the node 1, and I would have to like maintain a vector of integers. So let's write this code. First thing is that I am being given an integer n, the number of nodes, and then I am being given the edges, like n minus 1 edges. Here I will create an adjacency matrix of size m1 n plus 1. The reason I am creating for n plus 1 is because I am going to be having one based index here. And then let's run a loop of I is equal to 0 from I is equal to n to I is equal to 0. Basically, this is having n minus 1 iterations. Every time I will be having two things, so u and v, just take them as input. And then you can see that adjacency of u dot push back v. Okay, so only one. Like one is the like two is the child of one. Yeah, so it is a one-way connection. It is not indirect, like bidirectional. It is unidirectional, or basically a directed graph. Now, what I can say is something like just apply a DFS function starting from one. You must have a parent thing also, and the other thing you require is ADJ, which is the adjacency matrix. And here you'll be having something like avoid DFS. int node, int back, and vector of int adj, adj, and you should have something like a vector also, like the matrix I was discussing, not a vector but vector of vector. It's but I was the vector of vector I was discussing about. Let's give it as a name A. The name is not group, and the size is going to be n plus one. Or maybe let's just give it as like create a vector of A like this, and pass this as well. Maybe a vector of A array, and here we just say that in case if the node, like the adjacency of node of this is empty, if it is empty, then it means that this is the leaf node, right? Um, Only for the leaf node, it will be having zero elements in the adjacency matrix. So for that, like in that case, what you will say is that A of node dot dot push back, let's see, and then return. For all the other nodes, like I think that there can be at max two nodes. Like yes, I just want to if there are several. So I think that there will be several possibilities. So just run a for loop here. The child of a digit, if child like this can never happen. This can never happen. So like it will be only having the children. So in that case, what I will say is that for auto IP and the A of child, just iterate there, and here you can see that adj of not adj but A of node dot push back IP. Basically, the all the leaf nodes which are possible. Let's name it as leaf. So all the leaf nodes which are possible from its children are gonna be pushed in this vector of integers, and like in this way I will be having the complexity is going to be bad, I think. If I have to just give the count, then it was not necessary to find everything. I could just like have a count here. Like I didn't really read the problem completely. That was my mistake. So the problem, you don't really need to find everything like this. You just need to have a count here. So it will have a count one. But there is some problem. Yeah. So what we will say here is that A of no plus A of child. I think I have not made any mistake here. But just to be, this was a mistake. I should pass in the reference here. And like here I'm saying that if the node is not having any child, in that case just call the value as 1, which is telling you what are leaf nodes which are reachable from that node. So this is the only leaf node, that is itself. And in case if the child, like the it is not a leaf node, then I will say that for all the children of that node, just add up their, like the leaf nodes which can be reached by their children. There will be no leaf node which can be reached by two different children, because this is a tree and not a graph. And let's see, like after this, what should I do? I should be taking the queries, the number of queries. So let's take the input here, and then you have to run a loop here for like while q minus minus, and we will be having two inputs x and y. It's x and y, and you have to tell the possible number of combinations. So basically, you just need to find like for like here it was 3 comma 4. So for 3 there are two possibilities, for 4 there is only one possibility. You just need to multiply them here. You just need to multiply them, and the number is gonna be like we don't have to do anything like mod, which is not going to required here. So you just need to see out a of x into a of y, and then I'm not having confidence whether I wrote things right or not because like I had messed up somewhere, and let's see if I didn't get lost. So it's not working. Yeah, I made a mistake somewhere. Let's see where is it. This line. So, this also. Yeah, at least it is coming till here. Like, are there number of questions? Yes. If I run this, yeah, the mistake is here. I didn't give it a size here because I had my mistake. My mistake. And the answer it is giving is incorrect, which means that the array is not filled up. DBGA. Yeah, the array is not filled up here. Maybe because I might have made some mistake. So let's see what is the problem. For int I is equal to 0 till I is less than equal to 1. Just go to all of them and dbg. dbg zero comma 2. Okay, 7 child 2 and this is 7 child 4. Okay, so let's try to do this. Maybe I might have make like this is a really bad habit of mine that I don't really read the problems properly and just assume that they might have been trying to say this. So if child equal to full tab and just continue, and if it is having like if it is having only one size. Okay, so it's really cool. For one there is child two, for two there is a child one, and they have said one, three, three, four, five, three. Yeah. So they are not like these are not directed edges. These are undirected edges. My assumption was wrong there. And the code is also wrong. I think seven just one for this guy and nothing else. So I made one mistake. But I should check if it is a node zero equal to the path. In that case, just return it. Oh, it's still not low. This time it should not be right and like that and BFS. Now I am feeling that I should cut this part in the editing and then post it on YouTube. Like after that, 22144 221 4412 412, yeah. And like I think that I have still missed up a edge case. Like I have not dealt with an edge case. Let's see if the test cases are written here. 12142 12142, yeah. And like can there so there will be at least two more, so it will never happen that the first node is not having anything. And like right now I'm not in the mood to debug the code if it is having any problem or not. Just try to submit it. If it fails then we will debug, otherwise that's it. Okay, it got accepted. And now for the last of the fifth problem. I'm having even a worse rank now. So let's see for the problem. Like I think that This one also will also be done by us. And the F problem is something I'm not getting why that it can be done by me. It is which one has more solutions. The F1 like is having more solutions than F1. So let's try this. Let's call the segment LR beautiful if the number of ones in a segment is strictly greater than the number of zeros. For example, I'm just talking already. So the basic thing, I will be given few queries, and it's not bad to assume that the number of queries is going to be equal to n for almost every time. The hard problem, at least for the test case, which will give TLE, it's going to be like n every time. And I think traverse over the over all of the elements. Four hundred people have already done the e-problems, so it should be doable, I think. So one approach which is coming to my mind is something like if I like apply a binary search here, uh, I know that like the minimum number of operations is zero. Obviously, there will be no like we will never get the answer as zero here, and the maximum number of operations you're applying is q. So if let's say there is some like the answer lies somewhere here, and like if my mid is here when I'm applying the binary search, if my mid is here, so the obvious thing is that I can create a prefix sum like predicate function in which when I pass this mid and it will calculate if there is at least one beautiful subsegment, then it will give me one here. Like if I can build this, then like it will give me zero here, one here. So I can apply binary search here. If I can like create a predicate function, and for thinking about how to create a predicate function, I'm going to check for let's say three queries. Then what I will do is I will create like I will just create this thing. I will create this array. The array is actually like this array. This array. So I will create an array like this. So like I will create an array having all these elements as one, and now I can actually check for all these queries in nlogin. Like there can be more different methods, when the more optimized methods maybe. But one of the methods can be using nlogin. Like I can just build a segment tree for this, which will take somewhere around 42 n time complexity. Like I think that it will take 4 into n. I sorry, like I forgot what is the time complexity for building it. But every time I build a segment tree, yeah, I can just create a build function, and like every time whenever I build it, so I will just have to iterate over this, and every query is gonna be resolved in login, whether it is true or false. And so the whole predicate function will take like somewhere around n login. I don't care if it is n login or 4 login. I will at max have n login, and for applying the range, it will have something like log of q. So n login log q is gonna pass, and like there can be different approaches also. So GitHub, I will just go to my hub and segment these from there. Segment these. Let's take the input. So I'm an ender. I will say it as an ender, like exercise, and then I will create an array. I'm gonna be naming it A because it looks cool like this. And just take the inputs. No, not inputs. It's gonna be zero here at the starting, and like I will have this is an array, and this is gonna be the segments. Maybe let's call it as okay. So it's gonna be APIB, and then I will have like I will. Oh yeah, in case if someone don't know, like this is vector of integers and this is vector of pair of integers, and now I can just take all the segments m number of segments. So I will just take bi dot first and bi dot second as inputs. And after doing that, what I have to do is apply binary searches. So I will select start equal to one. Like there should be at least one query. The number of segments are more than one. At least there are one segments, and initially all of the elements are zero. So there will be at least one, and at max the number of operations you would have to use is q. And initially we are saying that the answer is minus one because like there might be no queries which q. Yeah, I'm not written it here. So there will be q queries. Not queries but like the operations, and there let's create a vector c of size A. And like I'm having very bad names, so just fill it up and then you will see the price start is less than n, then you have mid equal to start plus n by 2, and then you check equal to is valid. If the check is there, then in that case you will say that answer equal to mid and you want to minimize it, so answer and is equal to mid minus 1. Otherwise, you will say that start equal to mid plus 1, and at the end you will just see out the answer. And for every is valid thing, like you never had to use this. To be honest, let's give this as an AP. Let's give this as an UV. And now let's create a function is valid. The parameters to be passed in the function are going to be n, m, and the array b, and the array c, and mid of course. So now what you will have here is n, m, vi, b, and vi, c. I think q was also being passed here, or no, q is not passed here. This is the problem. No, no, C was not declared. Oh, sorry. I had to give A and B here. These are A and B now. And here we will create a vector of there are something like this. AI ARR of size n. And just go here. No, basically, we will traverse this array B from 0 till mid minus 1. Why mid minus 1? No, less than mid till it is less than mid. And now we will just say that like bi is gonna be telling me at which index you want to. Yeah, I had to do one more thing. I had to say that ai dot fi minus minus and ai dot se minus minus, and here I also had to say that x minus minus for converting it to zero based indexing. And here I can say, and here what I can say is going to be something very. Here are of b of I equal to full, equal to none. Okay, and then you will build a segment tree for this array. So what I am thinking of doing is just let's build a segment tree every time. In case if it gives a TLA, then we will do something else. We will take the seg tree. So we will build a seg tree here. Array era. In my template of seg tree, you just pass on the array for which you want to build. And like after this, what we will do is we will traverse to all the segments all these segments which are like M, there are M segments. And you have asked like NMAB. Yeah, NMAB. And it's having some problem. What is the problem? Yeah, I got it. So it should be VPI. The problem should be. And now what I have to say here is that, oh yeah, I have not built the segment tree. So let's build a segment tree. It will just have some, and here we'll just say that left dot sum equal to left dot sum plus right dot sum. And here you can just say that return val. So the segment tree setup. Now it will give me like sg dot query, and the query will be having a range, I guess. The query should be having a range, yeah. So the range is gonna be from 0 to n minus 1 because of the array, and then the sum. That's what I want. And yeah, like it's not necessary, but like I'm just writing it like this now. So int ram is equal to L minus V if V is greater than rem. Like rem is one of these are the ones, and these are the zeros, and this is the length. Let's say leng of the second. So if ones is greater than zeros, in that case he will return true. Otherwise, again he will return false. And now let's try to run this code. I think I took quite a long time in writing this. It would have been better if I was not actually explaining. Can you explain it to me? Okay, so the answer is from here. It's not even getting there. E dot se. Oh yeah, sorry, it should have been a. I had changed the name and I forgot about it. Yeah, like there's nothing. I have to find for ai.fe till ai.se here, and it's giving me like that it's terrible, but it's very bad. So let's say a Mara and the mid also. So for mid is equal to 3, and from the mid is equal to 1, yeah, it's good. So there must be some problem in segment trees then. For the segment trees, I'm having a sum which is 0. Here it should be val, which is other one is 0. And the sum is going to be left option plus right option. So like the segment tree should also be working fine. And we can confirm this by asking it here that just print dbg once length and zeros, and it should print I also. Okay, let's try this. So the last part, zeros, is incredibly wrong. Oh, sorry, I had to write one sum. Yeah, I wrote it. I wrote it. So 3 minus 1, 3, 3, 3, 1. Yeah, so the answer is correct now. Let's try to run this. Like it might work, it might not work. I have written the code pretty badly, so like there might have been some type of mistake or some other sort of mistake by me. Yeah, it passed. Like, I'm still having pretty bad line. Here it should have been somewhere around this range, maybe like 300. 115 people have done the F problem, so I think that we can at least try this. As is, no, a master is not able, like, if he has not done this, then I think like, maybe we can skip this also. As is known, um, just a couple of words that I need to Oh yeah, I had not explained the last problem, I think. So in the last problem, what was happening was that I was having so in the last problem, I was having an array, and there were some segments. Like I was being given some segments, and I was being given some changes. Like one change happens here, the other change happens here, the other change happens here, and they are going to be happening in some order, like in the order which I am being given. So I had to tell that like after which change there will be at least one segment in all these segments in which like initially all the values were zero in the array, and I have to tell that which of these queries like which is the first query, which is the first change after which there will be at least one segment in which the number of ones is greater than the number of zeros. Ones is greater than equal, not equal, but strictly greater than zeros. I had to tell that. So what I did, like I just thought of using a binary search. Like since a contest is going on, so here I don't have the time that what I was thinking before binary search and how did I get to this. But once I thought of a binary search, so it came in my mind that yeah, I know that at least the number of operations I will use is one, and the maximum number of operations I will have, like the maximum number of changes I will have is q. And if like after some change, like there is at least one segment, then obviously since an every change I am just making a 0 to 1 or keeping a 1 to 1. It's not gonna happen that after this, like the segment which got like the segment which got the number of ones greater than number of zeros will keep having it for all the other operations also, and before this all the other operations will have no, like no segments with some greater than, like number of ones greater than zero. So like I realized that I can find this part in log of q if I can create a predicate function, and by using a segment trees, I am able to like create a predicate function in nlog n also. And there can be some other ways also, like sorting the ranges and then going like linearly. So there can be even more optimized solutions than this, but segment trees is pretty easy to write. Like I just have to copy paste the code of segment trees, and then using it is really easy. I don't have to write a lot of code, so that's why I use segment trees. Since like here I had realized that it will also pass in case of time complexity. So now let's see the F problem. Uh, he has done this. Let's try our best. Though he is better than me, so I'm not sure if I will be able to do it. Like in capital on science, well-developed illustration, the this metro consists of certain number of stations connected by tunnels, and between any two stations there is exactly one path that passes through each of the tunnels no more than once. Sorry, I didn't read the problem. I didn't understand. I was just reading. Yeah, I will go ahead and send you the So, each of the between any two stations, there is exactly one path that passes through each of the tunnels. So basically, it is a tree. Yeah, it is also been mentioned here. To develop a illustration, home weight minus one. The station is having a weight. Okay, if the station has a weight minus one, then the station is having minus one. Instead, is charged plus so divided by total. Okay. One to consist of only one station with number one and weight one. Every day, one of the following events occurs, and the station with weight x is added. X can be either one or minus one. So with a number v, and it is assigned a number that is greater than the numbers of the existing stations. Okay. And Alex relation numbers, is there a subsegment possibility of the path between vertices u to be such that the traveling along it exactly k meters can be found if k is less than 0, then this kind of problem. In other words, Alex is interested in whether there is such a segment of the path such that the sum of the weights on the vertices in it is equal to k. Note that the subsegment can be empty and the sum is equal to 0. Okay, so if we ask for the sum to be 0, then I'll start to print yes. You are a friend of Alex, so your task is to answer. Like, everyone should have this kind of friends. Like, you are a friend of Alex, so you have to do his job. Like, what is this statement? First comes the symbol plus, which means that two numbers vi, xi, and the vertex with vi exists. In this case, the illustration will be at x is added to illustration with number pi. Okay, and first comes with symbol this, and it means that you are asking for u to v. Since there is only one path between u to v, it is connected with the vertices with the axis and this. So for like there is only one path between u to v. So basically we have to apply something like dp on trees, which uh, I generally fail to do. Like I have never been able to solve a problem in this during a contest. And like I think that it's gonna be solved by the other person. Okay, so here I'm already being given that UI is always gonna be equal to 1. So applying DP is really easy. Yeah. So now applying the DP is gonna be quite easy. Which one? I'm gonna be applying. Let's say so they're not having any explanations here. Let's see if they have made any explanations in this part. Uh, but like I think that the logic to me is like the logic which is coming to my mind is only correct. But let's say anything. It should give false for the first query. Yeah, it is giving no. For the second query, 1 to 2 with 1. So the path must not exactly give us how is it? Yes, then traveling between 1 to 2, 2 is the minimum here, which has a minus 1. Yeah, you are telling that you can earn 1. So, like, it means that you must not have 1 and 2 as the uh, which is like it's the vertex at corners, the endpoints. Let's see if there is any subs. Okay, so if there is any subsegment, yeah, got it. So like if I traverse from one to that number, then I can tell if there is a subsegment or not. That way. So like by just reading this problem, I'm pretty sure that I cannot solve this problem in any cost, at least for now. So like the whole time remaining I have is going to be spent on the E problem. And like two people have solved the F problem in my this, and I believe they will also solve it pretty soon. People have solved and like 193 people who have solved it. Okay. One method which is coming to my mind, but it is really costly, is that I'm not sure if it will pass, it can pass or not. But the thing which is coming to my mind is that like I'm having 1 year and there can be anything. And this is since this is a tree, so there will be only one path. So let's say that this is 16, this is 4, this is 5, this is 6, and it asks for the query like u is 1, which is always gonna be 1, v is 5, and it can ask for any k. So what is coming to my mind is that like it will have some value. I will create a set for this node, like for this node, and when I go to this node, like it, let's say it is have one. So here I will have a hash map for this node also, in which I will store that 1 and 2 can be like, I will just store that if any of these things come in the query, then I can answer it in one go. For this, I can say that, like, if, let's say if it is -1, then I can just say that if a query of either 1, like -1, 0, or 1 comes, then I can answer it directly. But the problem with this thing is that if there is like, if the tree is like a linked list of n size, then like at this place I am passing on one value to this. It will have two values, not actually two, but it might have three values. After this, you are again passing a value. So all these values are gonna be copied and some new values will be created, which will keep happening till the last node, and like the last node, which is the like n minus one node, let's say. So it can have a lot of values which can be created, or maybe not, like it will be having maybe minus into any of these. So something like 2n values at max, 1 plus 1 values at max. But still, passing on this again and again is still a very costly process. And if I'm gonna be asked for this, so how can I answer the query in log in time, or maybe square root of n time? I have to answer the query in any of these two things. Okay, so I need to think more about the problem. I think that I will not be able to solve the F1 problem. I'm not getting much of an idea. I'm not even progressing now. So I think that I should close this screencast now and just try to do it off screen. And in case if I get bored, then I will just leave it for contest for now. So thank you for watching till now, and bye.